Hello everyone, this is our session 9 on vectors. Today we'll do vector triple product. Okay, so that is your last topic for this chapter. Let us begin. So again, in vector triple product, we have scalar triple product and vector triple product, that is dot and cross again. So let us begin. We'll do the properties first and then we'll go on to the sums. Okay, first one, scalar triple product. Now, what is scalar triple product? So, if we have three vectors A bar, B bar, and C bar, okay, then B bar cross C bar is a vector perpendicular to the planes of B and C. The scalar product of A bar and B bar cross C bar, which is A bar dot B bar cross C bar, is called scalar triple product of the vectors A bar, B bar, and C bar. So, basically, A bar dot B bar cross C bar is called as the scalar triple product, okay, also denoted by box product of A bar, B bar, and C bar. This is called box product, okay. And how would we find out this value? So I'm just giving you the final equation. A bar, B bar, C bar is equal to A1, B1, C1, in the column this should be rather A1, A2, A3, B1, B2, B3, and C1, C2, C3. Okay. You can check for the proof in the textbook. It's quite simple that way. Find the cross product and then take a dot product with A bar. Okay. Then properties of scalar triple product. So first property is that if the order of A bar, B bar, C bar is changing cyclically, then the value, that is A1, A2, A3, B1, B2, B3, and C1, C2, C3 in box remains the same. Okay, so you can write this property as A bar, B bar, C bar box product is equal to C bar, A bar, B bar is equal to B bar, C bar, A bar. Okay, that is just changing the order cyclically. If you change the order cyclically, then the any one scalar triple product is correct. Okay. Second property, a single interchange of vectors in a scalar triple product changes its sign. That is A bar, B bar, C bar. Okay, now if I change to B bar first and A bar next, then the sign changes. Okay, which is equal to minus A bar, C bar, B bar. Okay, which is equal to minus C bar, B bar, A bar. Now, if you change any two vectors, then the position of any two vectors, then it becomes a negative of the ABC product. But if you change all the three, then it will be the same. Say scalar product is commutative. Now, what does that mean? So, if I have A bar dot B bar cross C bar, okay, which is equal to B bar cross C bar dot A bar. Okay, same way, if I have the scalar product with B bar dot A bar cross C bar, okay, then it is equal to A bar cross C bar dot B bar. A bar cross B bar, sorry. Okay, then B bar multiplied by or dot C bar cross A bar is equal to C bar cross A bar dot B bar, and C bar dot A bar cross B bar is equal to A bar cross B bar dot C bar. Okay, so it could be multiplied in any manner. It is commutative. Okay, if B bar and C bar are collinear, then B bar cross C bar is 0. Now this we have done in cross product properties also. Collinear, that is, they are either parallel to each other. Okay, so when they are parallel, angle between them is 0. So sine 0 is 0, and therefore A bar dot 0 will become 0. Okay, so basically the scalar triple product becomes 0 when any two vectors are collinear. Thus, if in a scalar triple product any two vectors are collinear or equal, then the scalar triple product becomes 0. Okay, that was the 4 properties. Fifth one, if any one vector is a 0 vector, then A bar, B bar, C bar is 0. That you can understand from the determinant value itself. So we have A1, A2, A3. Okay, B1, B2, B3. And C1, C2, C3. Now, if I have any one row as 0, that is, let's say this as 0, okay, A vector is 0, then the scalar triple product becomes 0. And then if ABC are coplanar, then so there are three. If ABC are coplanar, that is lying in the same plane, then their scalar triple product is 0. If any one vector is 0, then their scalar triple product is 0. Now the next topic is volume of a parallelepiped and volume of a tetrahedron. So here we are going to directly use the formulas. We don't have to do the proof. So volume of a parallelepiped. You know what is a parallelepiped? You can say a cuboid also. Okay, wherein not all sides are same, not all edges are same. Volume of a parallelepiped is the box product of the three edges of the parallelepiped, A bar, B bar, and C bar. Okay, coterminous edges, that is height, base, and length. That is volume of a parallelepiped. You don't have to do the proof of the same. Then volume of a tetrahedron. Volume of a tetrahedron again. Volume of a tetrahedron, coterminous edges A bar, B bar, C bar is. Here also we have to directly only do the formula. So volume of tetrahedron is equal to 1 upon 6 bracket A bar, B bar, and C bar. 1/6 of A bar, B bar, and C bar. Okay, this was about the scalar triple product. Now moving on to vector triple product. Again, vector triple product, you don't have to do the proof. We have to directly only write the triple product. So what it will be? All the three vectors taken in cross product. That is A bar cross B bar cross C bar. Okay, which is equal to A bar dot C bar into B bar minus A bar dot B bar into C bar. Okay. The definition of a vector triple product is remembered as outer dot remote into adjacent minus outer dot adjacent into remote. Okay. Now, if A bar, B bar, and C bar is A bar is outer vector, B bar is adjacent to it, and C bar is the remote vector. Okay. So, thus B bar cross C bar cross A bar. Now, properties of vector triple product will be is it commutative? That is, can we write their order as opposite and get the answer? So that is negative. That is A bar cross B bar cross C bar is equal to minus of B bar cross C bar cross A bar. This is same as your vector triple product property. Then A bar cross B bar cross C bar is equal to A bar dot C bar into B bar, okay, minus B bar dot C bar into A bar. sorry, into A bar. Okay. Now this one property is very important. A bar cross B bar cross C bar, okay, is not equal to A bar cross B bar cross C bar. That is basically you cannot just open, or you can't use the distributive law over here. Okay, A bar cross B bar cross C bar is a linear combination of B and C, and hence is coplanar with B and C. So basically this vector over here is coplanar with B and C. Okay, B bar and C bar vector. Okay. Last property of vector scalar product, vector triple product is I bar cross J bar cross K bar is equal to 0. Okay. Okay. Now let us begin with exercise 5.5. Okay. I'll do the very first sum only. Find A bar dot B bar cross C bar. So you have to find the scalar triple product A bar dot B bar cross C bar if the three vectors are given. Now what are the three vectors? A bar is equal to, B bar is equal to, and C bar is equal to. So what are they? 3i minus j plus 4k, 3i minus j plus 4k. Okay. B bar is equal to 2i plus 3j minus k. Okay. And C bar is equal to minus 5i plus 2j plus 3k. These are the three vectors. This is a scalar triple product. How do you get that scalar triple product? So we have A bar dot B bar cross C bar given by the three vectors A1, A2, A3, B1, B2, B3, and C1, C2, C3. So basically we are going to substitute all the coefficients over here. Three minus 1, 4. 2, 3 minus 1. And minus 5, 2, 3. So take your determinant values, 9 plus 2 minus of minus plus 6 minus 5 plus 4 multiplied by 4 plus 15, okay, which is 33 plus 1 plus 4, 19, 76. 110 is the answer. So this is your value. Let's move to the next one. If the vectors are the coterminous edges of the parallel pipette, then find the volume of the parallel pipette. So basically the three vectors are given to you. Okay, A, B, and C, and you have to find the volume. Now volume of a parallel pipette is a scalar triple product, so I would not do this one. Okay, next again third sum, if the vectors are coplanar, then find the value of P. Now if vectors are coplanar, what do we know about the scalar triple product? It is equal to 0. So I'll do the third sum now. Okay. So if the vectors, so let's take A bar equal to minus 3i plus 4j minus 2k, okay, and B bar is equal to I plus 2k, C bar is equal to I minus pj. Now here they have said that these vectors are coplanar, then find the value of P. So I have to basically find this coefficient. Now if these are the three vectors, then you say that A bar, B bar, C bar are coplanar, lying in the same plane. Okay, and when vectors are coplanar, then their scalar triple product is equal to 0. Okay, so basically the box product A bar, B bar, C bar equal to 0, which will be A1, B1, A2, A3, B1, B2, B3, and C1, C2, C3 equal to 0. Let us put the values now. So A1, A2, A3, minus 3, 1, and 1. B1, B2, B3, 4, 0, and minus P. 4, 0, minus P. C1, C2, C3. Oh, sorry, 1 second. 1 minute. Just substituted the wrong values. Minus 3, 1, 1 would be here. Then 4, 0, minus P. And minus 2, 2, and 0 is equal to 0. Let us put the determinant value now. 0 plus 2p minus 4 into 0 minus 2 plus minus 2 into minus p plus 0 equal to 0, which will be minus 6p plus 8 plus 2p equal to 0, minus 6p plus 8 plus 2p equal to 0. That is 4p equal to minus 8, p is equal to 2. This is the value of p. Okay, now there are proof that sums. I'll do one of that for you. Question 4, first one. The box product of a bar, b bar plus c bar, and a bar plus b bar plus c bar is 0. Is equal to 0. We have to prove this. So let us begin. So now basically this is a scalar triple product. So scalar triple product will be a bar dot b bar plus c bar. Okay. Cross product of a bar plus b bar plus c bar. Okay. Which is equal to a bar dot b bar cross a bar plus b bar cross b bar Okay. Now remember, cross product of the same vectors is 0 because angle between the same vectors would be 0, sine 0, 0, and therefore that will be 0. So we have c bar cross b bar and c bar cross c bar and b bar cross b bar as 0. Okay. So first we can do that. We can put the values that are 0 as 0, b bar cross a bar b plus 0 plus b bar cross c bar plus c bar cross a bar plus c bar cross b bar plus 0. So now we have b cross a, b cross c, c cross b, and c cross a. Okay. So the next step would be equal to a bar dot Okay, now I'm giving the dot product to each one of them. A bar dot B bar cross A bar plus A bar into 0, that is 0, plus B bar cross C bar. So plus A bar dot B bar cross C bar. Okay, plus A bar dot C bar cross A bar. Okay, plus A bar dot C bar cross B bar. And the last one would be 0 again. Okay. Now A bar dot B bar cross A bar will be again 0. Okay. Then plus A bar dot B bar cross C bar. Okay, plus 0 again, plus A bar dot C bar cross B bar. Okay, basically now if you can look at this and this, so this is cross product has been reversed. So that means this one would be negative of the first one. Okay, that is plus A bar B bar dot C bar, sorry, cross C bar minus A bar B bar cross C bar. Okay, and they cancel out, and so your final answer is 0. Therefore, we have the value as 0. Okay, try the second one on your own. If you have a doubt, you can let me know for that one. Okay, now moving on to question 6. If U bar, R bar and W bar are given vectors, then find U bar plus W bar, U bar cross R bar into R bar cross W bar. Okay, so basically you have to find all the paths separately, and then you take the scalar triple product. Okay, so let us begin with the three vectors that have been given. Question 6 I am on. Okay, if U bar is equal to okay, question 6 now. So we have three vectors. U bar is I minus 2j plus k. Okay, I minus 2j plus k. We have R bar equal to 3i plus k, W bar equal to j minus k. Okay, are given vectors. Then find U bar plus W bar. Okay, then we have to find U bar plus W bar. Okay, one bracket dot product with U bar cross R bar cross R bar cross W bar. Okay, now this what we'll do is we'll find each one separately. So let us begin with the first one, U bar plus W bar. Okay, which is equal to adding of these two vectors U bar and W bar. So I cap minus 2j cap plus k plus j minus k. Okay, which is equal to I plus I is not there, so I cap as it is, minus 2 plus 1 is minus 1j. Okay, plus k minus k cancels out, so I minus j. Now let us find out U cross R. So U cross R, U bar cross R bar is equal to I, j and k, and the coefficients of U are 1, minus 2 and 1, and that of R are 3, 0 and 1. So 3, 0 and 1, which is I cap multiplied by minus 2 minus 0 minus j multiplied by 1 minus 3 plus k multiplied by 0 plus 6. Okay, so this will be minus 2 I cap plus 3 j cap plus 6k U bar cross R bar. Okay. sorry, 1 minus 3 here would be minus 2. So sorry. Minus 2 plus 6k. Plus 2j plus 6k. Okay, that is u bar cross r bar. Then we have u bar cross w bar, I think. Let me check the question. Sorry, r bar cross w bar. So this will be r bar cross w bar. Again, substitute the values I, j, and k. Okay, and then put the values of r bar, that is 3, 0, and 1. 3, 0, 1. Then of w is 0, 1, and minus 1. Okay, and then that vector will be equal to minus I plus 3j plus 3k. Minus I plus 3j plus 3k. Okay, we have the three vectors. Now we are going to take the scalar triple product. So u bar plus w bar dot bracket u bar cross r bar cross r bar cross w bar. Okay, this is scalar triple product, if you can see, cross r bar, okay, which is equal to basically the box product of all the three vectors. So what are the coefficients of the first vector that we found out? It is 1, minus 1, 0. Okay, then the second vector is minus 2, plus 2, and 6. And the third vector, minus 1, 3, and 3. So this answer comes up to minus 12. Okay, this is how you would solve this sum. Now the remaining questions I'll leave up to you. It's very simple, just on the same lines. Okay, I'll just do one question of vector triple product so that you know the method of solving it. I'm doing question 8. If a bar, b bar, and c bar, then verify that a bar cross b bar cross c bar is equal to a bar dot c bar into b minus a bar dot b bar into c. Okay, it's basically verification. So what we have to do here is take down the three vectors. Okay, a bar, b bar, and c bar. What is that? So we have I plus 2j plus 3k. Okay, 3i plus 2j. Okay, and 2i plus j plus 3k. Three vectors. Now verify that the triple product, that is a bar cross b bar cross c bar, okay, is equal to a bar dot c bar into b, okay, minus a bar dot b bar into c. So what we'll do is we'll find b bar cross c bar first, okay, which will be I, j, k. What is the coefficients? The 3, 2, and 0, 2, 1, and 3. Okay, so what is the vector that we get after multiplying? 6i minus 9j minus k cap. Okay, this is the b bar cross c bar. Then a bar cross b bar cross c bar is equal to, again, I, j, and k. Take a bar coefficients 1, 2, and 3. And take b bar cross c bar coefficients, that is 6 minus 9 and 1. 6 minus 9 and minus 1, sorry. Okay, and the answer to this would be 25 I cap plus 19 j cap minus 21 k cap. Okay, now this is your left hand side. Now let's check for the right hand side. So in the right hand side we have a dot product, that is a bar dot c bar. So what you do is you take the two vectors and take their product, that is I plus 2j plus 3k. So I plus 2j plus 3k. Okay, and your C bar vector is 2i plus j plus 3k. 2i plus j plus 3k. Okay, now you have to multiply this. Now it's a dot product. So remember, dot product for same vectors, you'll get a value. For different vectors, it is 0. Okay, because cos 90 is 0 and cos 0 is 1. So I dot I is 2. So basically you will have 2 plus j dot j, that is 2 into 1 plus 2 plus 3 3s are 9, that is 13. Okay, then multiplying of a bar dot c bar into b bar is equal to 13 into the vector. What is the vector b bar? 3i plus 2j. Okay, so we have to multiply this. So we'll get 39i plus 2j, that is 26j. Okay, this is a bar dot c bar into b. Now a bar dot b bar. So a bar dot b bar. Let's take the dot product of these two vectors now. So what is a bar? I plus 2j plus 3k. I plus 2j plus 3k. And 3i plus 2j. Okay. So basically I into I, that is 3, j into j, that is 4. K is not there, so 0, 3 plus 4, that is 7. Okay, so a bar dot b bar is 7. Now a bar dot b bar into c bar is equal to 7 into, what is the c bar vector? 2i, j and 3k. So 2i plus j plus 3k, okay, which is equal to 14i plus 7j plus 21k. Now what is the right hand side exactly? It is a bar dot c bar into b bar minus a bar dot b bar into c bar, okay, which is equal to 39i plus 26j, okay, minus 14i plus 7j minus 21k plus 21k. Okay, so the answer to this is 25i plus 19j minus 21k. Yes. Okay, so this is your final answer. Now you can see that 25i plus 19 minus 21. Look at this that we had, 25i plus 19 minus 21. So this is how you would prove the vector triple product. Okay, we are done with this chapter of vectors now. If you have any doubts regarding any of the exercises, do let me know. I will solve them separately and send to you. Thank you so much.